Welcome to Ms. Park's Flipped Classroom. In today's lesson, we're going to talk about completing the square, and the objective is to solve equations by completing the square and to rewrite functions in vertex form by completing the square. Well, completing the square is a method used to rewrite a quadratic equation or function into a perfect square trinomial, and you do that by adding b divided by 2 squared to both sides of the equation. So let's look at an example of a quadratic that we solve when b is equal to 0, when it only has the x squared but no x. Our steps are first to isolate the x squared, and then we take the square root of both sides. So in this example, we would subtract 10 from both sides, divide by 4, and then take the square root. And remember, important point, when you take the square root of 9, we have to do the positive and the negative roots. So our answer is x equals a positive 3 and a negative 3. This is where our graph would cross the x-axis if we were to graph this quadratic. Okay, here are your got it problems for you to try just like this example. So we're going to add 10 to both sides. 7x squared equals 35. Divide both sides by 7 and we get x squared equals 5. Take the square root of both sides and we get x equals a positive or a negative square root of 5. On this one, we need to subtract 9 from both sides to get rid of that. That leaves us 2x squared equals 4. Divide both sides by 2. We get x squared equals 2. Take the square root of both sides and you get x equals a positive or a negative 2. And that would be your answer. Positive or negative square root of 2, and that would be your answer. Before we complete the square, let's look at how we solve a perfect square trinomial. We know that this is a perfect square trinomial because this is a perfect square, 4 is a perfect square. If I take 1 times half of this, which is 2, and then multiply that times 2, I get 4. So it meets the test for a perfect square trinomial. So I know that x plus 2 times x plus 2 will multiply to give me this trinomial. So I can write that as x plus 2 squared equals 25. Because everything that's squared is inside the parentheses, I can take the square root of both sides. The square and the square root cancel each other to leave me x plus 2 equals, remember, plus or minus 5. So now I have 2 equations that I have to solve. One is where x plus 2 equals a positive 5, and the other one is where x plus 2 equals a negative 5. So I subtract 2, get x equals 3, subtract 2 and get x equals a negative 7. So my 2 answers are 3 and negative 7. The got it for you to practice on is x squared minus 14x plus 49 equals 25. Perfect square, the middle term meets the requirements. So we know that this will be x minus 7, the square root of 49. The minus, because that's minus, equals 25. Take the square root of both sides, and we get x minus 7 equals a positive or a negative 5. Set up our 2 equations. X minus 7 equals 5. Add 7 to both sides, and that would give us x equals 12. Our other equation, x minus 7 equals a negative 5. Add 7 to both sides, and we get x equals 2. So our answer is x can equal 2, and x can equal 12. In this example, this is not a perfect square trinomial. This is not a perfect square. This is a perfect square, but this isn't. So we're going to complete the square and make it into a perfect square trinomial so we can work it like the problem in the slide before. So the first thing we're going to do is rewrite it so that the variables are on the same side and all the constants are on the other side. So if you look at this problem, we need to subtract 9 from both sides, which gives us 3x squared minus 12x equals a negative 9. It tells us if a is not 1, we have to divide all the terms by a. Well, our a is 3, So we have to divide each one of these terms by 3. So that gives us x squared minus 4x equals a negative 3. Our next step says to add b divided by 2 squared to both sides. Well, my b, we're right here, is a negative 4. When I divide that by 2, I get a negative 2, and I square it, and I get a positive 4. So I add a positive 4 to both sides of my equation. And now this is a perfect square trinomial, and I can factor it as x minus 2 squared. Add those and get 1. Take the square root of both sides, and you get x minus 2 equals a positive or a negative 1. Set up your two equations, one where it's equal to a positive 1, the other one where it's equal to a negative 1. Solve your two equations, and you get x equals 3 or 1. Another example that's a little bit more difficult. We need to get the x's over here and the numbers over here. So we subtract x from both sides, which will get rid of the x on this side. Then we subtract 3 from both sides to get rid of the 3 over here and move the numbers over here. So now we have 2x squared minus 2x equals 6. A is 2, so we divide all the terms by 2, which gives us x squared minus x equals 3. B is a negative 1. So we do negative 1 divided by 2 squared gives us 1/4. So we add this 1/4 to both sides of the equation. This is a perfect square trinomial, so now I can factor it into x minus 1/2 squared equals 13 over 4. Remember to change this. You have 3 plus 1 over 4. It's 3 times 4 plus 1 over 4 is how I got 13 over 4. Next step is to take the square root of both sides, which gives us x minus 1/2 equals, well, the square root of 4 is 2, so there's no square root symbol on that anymore. And then the square root of 13, and we still have plus or minus. We add 1/2 to both sides, so that gives us x equals a positive or negative square root of 13 over 2 plus 1/2, which we would write this way because we can't add this 1/2 to this radical. So we have 1/2 plus the square root of 13 over 2 and 1/2 minus the square root of 13 over 2. The last thing we're going to look at is how to complete the square and write your equation in vertex form. So we have the equation y equals x squared plus 4x minus 6. We're going to replace y with 0 so that we have an equation that we could solve. And we'll have x squared plus 4x minus 6 equals 0. Remember, we want to get the numbers over here, the x is over here, so we did that. We don't have to divide because x is 1. B is 4. I'm sorry, A is 1. B is 4, so we substitute that in here. 4 divided by 2 squared is 4, so we add 4 to both sides. Remember, this is what gave us this. Now we can factor this. This is a perfect square trinomial, so it's x plus 2 squared equals 10. Take the square root of, oh, I'm sorry, we're not solving it. We just want to know vertex form. So now we're going to take this 10 and move it back over here. So we subtract 10 from both sides, which is going to give us x plus 2 squared minus 10. It will be this minus 10. This is gone to give us 0. Remember, vertex form is x minus h squared plus k. So we know that our vertex is a negative 2, opposite of what you see here, and a negative 10. So here's our vertex, and this is vertex form. If you want to go back to your standard form, you can find the y-intercept, which was 0c, so it would be 0, negative 6. You know A is positive, so you know your graph is going to open up and your vertex is a minimum. Your range, your y values are greater than or equal to a negative 10, so that's your range. And there's a sketch of the graph. The problem didn't ask for all of this, but I just put this on here to kind of tie everything together for you so you can see how this works.